If you are new to the channel, then subscribe the channel and press the bell icon for further notification. Okay student, welcome you all to this new lecture in machine series. So today again we will be solving 5 questions starting from question number 96 to question number 100. Okay, then let's try to solve these 5 questions. If you come to question number 96, which of these 3 connections can be used for in a transformer to introduce a phase difference of 30 degree between the output and the corresponding input? So star it will be either you can make it 0 or 180. You have seen either it is vector 1 group or vector 2 group, second group or first group or second group. Star delta, there is inherently 30 degree shift. Delta again it can be either 0 or here. Delta or zigzag either can be 0 or 180. So this is always plus 30 or minus 30. It is always there. In build there is a shift of 30 degrees. So it is obviously option B. Now if you come to 97, in transformer the following statement is valid. In an open circuit test, the copper loss is obtained. In open circuit means no current, so minimum current is flowing. So how come copper loss will come? Copper loss is always I square R. So full load I square depends on I square. So copper loss is never obtained, you cannot do it. And while in short circuit, core loss is obtained. Short circuit means maximum current is flowing. So it is not, that means you are getting, it is just reverse they have given. In open circuit test, no current is there. It is just the current for magnetization and the core, what is the current for core magnetization, and that ED current hysteresis loss. So in open circuit we get core loss, in short circuit we get copper loss. It is just reverse, so it is not the correct answer. Open circuit toss, the current drawn is at very high power factor. Open circuit toss means only magnetization portion is there. If you draw that equivalent circuit, only this portion is there, that magnetization branch and core loss. This is core loss, this is magnetization part, and rest is already, this is the equivalent circuit. So it is basically high inductance is there. So high inductance power factor will be very low in open circuit because this is open, only this branch is connected. So power factor will be very low. So OC is, that is wrong. So that means you can see option D, at open circuit test power factor is very low. So that means option D is the correct option. You can check C also. In short circuit it is at 0 power factor. Short circuit means everything, whatever winding, that is short circuited here. So 0 power factor means phi is exactly 90. It is not 90. There are winding resistances are also there, which is not exactly 0. So there are some winding resistance. So that's why it is not be 0 power factor. That means 0 power factor means phi is 90. That means it is properly only inductor is there. No, it is not like that. There are resistances also there. So D is the correct. In open circuit it is low power factor because high magnetization is there. So in question number 98, two transformers are to be operated in parallel such that they share load in proportion to their kVA rating. The ratings of the first transformer is, and their per unit impedance is this. The rating of the second transformer 250 per unit leakage. So we have studied this one. To share the load as per their kVA rating, their per unit impedance is in their respective bases should be equal. So on 50 kV if it is 0.05, on 250 kV also it should be 0.05. That is, per unit value should be same on their bases. Or if you come to common base, then it may change, but on their own basis, because the absolute value should be same. So if you find the per unit leakage impedance for this one, it will be 0.05 on the basis of this. That should be same as here also. Suppose it is 5 ohm. So 5 ohm on the basis of this, if it is 0.05, so 5 ohm on the basis of this will be also 0.05 because it is per unit on the basis of this. So that's why it is 0.05. So per unit value on their respective bases, it should be equal. Now in question number 99 and 100, a 300 kVA has a 95% efficiency at full load, 0.8 power factor lagging, and 96% efficiency at half load unity power factor, the iron and copper loss. Okay. The efficiency, if I am calculating, the full load efficiency at 0.8 power factor. So what is its output? Output is 300 kVA into 0.8, this much kilowatt, divided by 300 into 0.8, plus that iron loss and then copper loss. Suppose this is iron loss, this is copper loss. This is given 0.95. And half load. Half load means 300 by 2, that multiplied by unity power factor. So power factor is 1, so total kilowatt is this one. kVA into cos phi is equal to kilowatt. So this will be also this one. Iron loss will remain same, but copper loss, because it is half load, it will be divided by 4. It is given 0.96. So from here if you solve, you will find x plus y equal to 12.63. And from here x plus y by 4 is equal to 6.25. If you solve this one, so your iron loss will be equal to 4.12 and your full load copper loss, that is y, is equal to 8.51 under full load. So iron loss will be equal to, so you can see your option, it is option C. Iron loss is 4.12 and copper loss is 8.51. What is the maximum efficiency at unity power factor load? So for maximum efficiency at unity power factor, so total load is into 1 kilowatt. So maximum efficiency, your iron loss should be equal to copper loss. So both is equal to same. Just this should be equal to 4.12. So what is this one? If you solve this one, I think you will get, but you have to calculate at what value your iron loss is equal to copper loss, because that much power you are taking as output. It is full load, it is not full load. You don't know it whether it will be at full load or what. It is at unity power factor, they are saying okay, but you see at what point it is getting maximum power efficiency. So that we have seen using this formula. At what loading they should be equal. They are equal, I am writing, but at what loading? If you solve this one, I think it is 0.6957. So that has to be multiplied. So if you do this much loading, then they are equal. So at this much loading, your maximum efficiency will come. So if you take this one, I think you will get answer 96.2%. That is your option B. If you like the video, then press the like button and please give your valuable comments in the comment section.